Welcome back to the channel. Today we are doing an exercise which is very interesting called merge two sorted lists. So you have list 1 to 4 and then 1, 3, 4 and you need to return one list which combines them in ascending order. And the linked list is it's a list node which always has a next property, and the next property is also a list node. So every single list node object has a value, a pointer to a next list node, singly linked list. And what is a singly linked list? Well, a singly linked list, you can have like single link list has a value and a pointer to next. That means you can traverse it from the head to tail, because you always go to the next element and then the next element, because the next one also has a pointer to the next, and so on. And you can have a doubly linked list, which has a value and you have a pointer to next, and then you have a pointer to the previous. So it's a doubly linked list because you can traverse it from head to tail, but also from tail to head. Okay, this is just some extra info, but this example only handles single linked lists because as we can see, we only have one pointer to the next item. So how would we do this? Well, one way to do this is to use recursion. So essentially we have this method, public list node merge two lists. We will call it again and again until we have reached the end of the lists. We have 1, 2, 4, and this is the first linked list. And 1 stores a pointer to 2, 2 stores a pointer to 4, and 4 let's make like this, ptr to 2, 2 stores ptr to 4, and 4 stores a ptr to null, right? And because the next property of 4 is null, then this is the last element. So this is actually a check that we can make, and which we will make inside the merge two lists. Always when you have recursion, you need to ensure that you have the very first thing in a recursive method, you should have an escape scenario. And we will see immediately what that is. And then here we have 1, 3, 4. I'm just following the exact same example. Look, we want to compare. This is list 1, and this is list 2. So we look at, when we go through the linked list, we need to compare which of the current elements in our current call of the merge two lists, which one is the smaller element. First of all, we will handle the scenario when we have either list 1 is null, either list 2 is null, because as we keep evaluating the lists and we go recursively, we might receive a list argument that is null. That means we have reached the end. If list 1 is null, then we need to return the other list, because there's nothing to return from here. So if list 2 is null, then we just need to return list 1. Right, so now as we said, all we are interested in right now in order to complete the recursive call is which one of the two lists, which current element of the two lists has the smaller value. So we will be saying exactly that. If list 1 that value is smaller than list 2 that value, then list 1 is the one we are interested in for this call of merge two lists, right? So then list 1 that next is merge two lists of list 1 that next and list 2, and then we return list 1. So we will also have a scenario where list 1 that value is going to be equal to list 2 that value or greater. So then we just say list 2 that next equals merge two lists of, and in this case we are interested in the next, setting the next of the list 2 to yet another evaluation. but this time we are taking the list 1, or what's remaining of the list 1, and list 2 dot next, right? And then we return list 2, right? Let's delete the explanation here. So again, what happened here? Well, let's read it again. We need to apply recursion. We know that we need to apply recursion because this is a linked list. It's not an array like 0, 1, 2, n. It's not an array. It's a linked list, and in a linked list, we need to traverse it, like to go through every single element. In an array, we can jump to position, like give me element, I don't know, at position 2, which is this one. But in a linked list, we cannot just do that. So we need to go through every single element by going deeper and deeper into the next property and evaluating. So what happens here is we make this check. If either lists are null, we return the other one. Why do we do this? Because as we go recursively, we might encounter the scenario that we have passed. As we keep passing, give me the next and give me the next, we might, one of this next might be null. So when we enter, it will be received as null either here or either here, right? So, but if both lists are fine, then we need to evaluate the values. Output linked list needs to keep its sorted property. Remember, the smallest value item will be a head item. This is the head. So, if the value of list 1 is smaller than value of list 2, then what we want to return from the current iteration in our recursive step is list 1. And this is why we return it here. And we are going to continue the iteration by evaluating, by making yet another call to the exact same function. But this time we pass, okay, we are returning the list 1, but we are passing the next property, right? Why are we passing the next here? Because the current property of list 1 we have already evaluated on line 17 here, right? So we return the list 1, but not before we pass we assign its next property to the next evaluation of give me who is smaller from these two, right? Now, if it happens that this if does not equal true, then we don't return here, but we continue with the exact same thing that we do on line 19, except that this time we consider list 2 as what we return here, right? So we return list 2, but not before we set its next property to the next call in line for our recursive algorithm, which is what's left of list 1 plus the next list node in the list 2 linked list. The computational complexity. Well, we have time complexity. Let's think a bit. How much would all this take? Basically, we need to traverse these two lists. That's a fact. We need to go through every single item until we reach the very end of the list. So of every element, of every element in the first list plus every element in the second list, right? So entirely dependent on the length of both linked lists. Space complexity. Well, how much memory will this take? So if we look at this function, essentially it keeps calling itself until there are no more elements. So and because it's a recursive function, the initial call of merge to lists will not return until every single recursive call has completed. So I always as much memory as it takes to go through the first list, plus as much memory as it takes to go through the second linked list. Okay, thank you very much. Please subscribe and let me know if you have questions.